It is a cross-site scripting mitigation, and it really failed horribly in doing so. So after this talk, you should know how bad whitelist-based CSPs are in practice, because you will see them everywhere. Everyone who uses a CSP does it wrong. And also at the end of the talk, you should know how to build a content security policy that actually delivers some value. Who am I? My name is Lucas. I'm a security engineer at Google in Zurich. And I usually present this together with Michele. He's not here today, but he sends you greetings. We spent a significant amount of time, probably more than a year, working on CSP, investigating the problems of CSP, and also trying to propose a better way of doing CSP to actually deliver some value. Because we think that CSP is still one of the most promising mitigation techniques for XSS, but unfortunately very flawed so far. So I don't know, who of you already heard about CSP before in their lives? Awesome, so a couple of people. Who of you tried to actually come up with a CSP on their own, right, to protect, I don't know, a website or whatever? Okay, awesome, also some folks. So CSP is kind of a tool for developers to lock down the web application in various ways. It is a defense in depth mechanism, and as I said before, it tries to mitigate XSS. This is the primary use case. Very important, I want to stretch it from the beginning, this is not a replacement for careful input validation or output encoding, right? It's a second layer defense, if you do it right, a very effective one, but it does not replace the need of actual sane coding practices, right, and fixing bugs. So the goals of CSP have been pretty ambitious. As I said before, it was originally proposed to mitigate against XSS. As you see later, it currently fails to do so. It also, over the time, like a lot of additional stuff was added on top of CSP that is not really related to XSS protection, but most of that kind of stuff can also be delivered in different headers, right? So we'll not focus on that. And also some people propose to use it as a detection mechanism for exploitation of XSS, which also does not work very well because, you know, there's a lot of noise in the reports, and as a pen tester, you just usually turn CSP off in your browser, find the XSS, and then you try to bypass the CSP. So we'll focus on mitigating XSS here. A policy is usually delivered as HTTP header. There are actually two. The content security policy header is the normal one, which puts the CSP in enforcing mode. So we'll see that in a second, that it will actually enforce the policy in the browser. And the second one is just report only. It does not enforce anything, but it will report violations back. So a developer can find out, you know, where the policy does not match the site and can fine tune it. There's a lot of CSP directives, right? But most of them are pretty useless in terms of XSS protection. Quite often you see like a half-page long CSP that restricts image source, like the place where the browser can load images from for the site. That does not deliver any value for XSS protection, right? And just introduces risk of breakages. So in this talk, we'll focus almost exclusively on script source, object source, and kind of also default source because it's the fallback for both. But yeah, kind of not, try to not use all the other directives for XSS protection. I mean, you can do frame ancestors and this kind of stuff, but not the image source, font source, or stuff like that. They're really just a waste of time. So how does it work? On the right side, you have a content security policy, and on the left side, we have some website that embeds an image of a cat. So the cat image is on a relative path, and the default source says self. Self means in this context that the image is allowed to load from the same origin. In this example, money.example.com. So, you know, CSP will allow the loading of this image. But that's not really relevant for security. More interesting are scripts, because they can cause cross-site scripting, right? So in this example, the site also loads a script from yep.com. And as you can see on the right side, yep.com is on the whitelist, so it is allowed to load. Now let's assume your site, like the money.example.com, has a cross-site scripting vulnerability, right? An attacker could inject a script like that, script source attacker.com, and with this CSP, it will not execute because attacker.com is not on the whitelist. So it is blocked by the browser. The second example, script alert42 script, will also be blocked because script source does not allow inline scripts. Like an inline script is something like the second example. This is actually JavaScript between the script tags. So this is very theoretical, so let's do a quick demo. I can do an example with image source self. So this is the policy header. This is the HTML with a cat image, and on the right side, you see that the cat image gets rendered, right? If I'd be more restrictive here and say image source none, which means nothing is allowed to load, the browser will block the image from being loaded and will throw a console error like refuse to load the image, right? So this is just a trivial example. It is more interesting to see that with script source. So for example, script source none is super restrictive. You probably can never use that, or I mean, just maybe as a use case, but normal website usually needs to use some sort of scripts, right? And if you do that, right, it says refuse to execute inline scripts. So what you would need to do here is you would add unsafe inline, and then the script would execute. But as the name already says, it's unsafe, right? We'll come to that later. But it's right. I mean, most policies have that, right? So it's actually quite common that you see that in practice. But I have data for that. So, but it's hard to deploy, right? So if you have a complex web application, the application sources scripts from, I don't know, 20 different domains, CDNs, or whatever, right? And the thing is, so you have to keep adding stuff to the whitelist to allow the site still to function with your content security policy, right? So this is just, this is not something I came up with for this talk. These are the real world examples. The above one is Twitter. The below one is Gmail. This is just the script source part, right? I mean, it couldn't fit the screen with all the other stuff, so it's already pretty small, sorry for that. But if you pay attention, you maybe see already some problems there, right? Anyone has an idea why these policies are totally worthless for XSS protection? Yeah, it's, you know, it's, for example, the unsafe inline, which we just saw, but there's also other things, which we'll see in a second, that will allow to completely bypass the policy. So this is just to demonstrate that this is like really something you see in practice, right? So this part might be interesting for the pen testers among you. So how do we break all these bad CSPs? You know, there's a couple of common mistakes, which are really trivial, and then it will show a couple of more advanced bypasses, which are maybe not so obvious if you don't know about them. So we just discussed this case, right? Unsafe inline in script source. It completely removes the XSS protection capabilities of a CSP, right? Because an attacker can just inject a script tag as he would be able to do so without the CSP. So, but this is still very often encountered in practice because, you know, otherwise the website doesn't work, right? So, yeah. The other one is kind of broad whitelists, like wildcards. If you do something like that, if you say script source self and then HTTPS or data or star, it basically means that the attacker is allowed to load anything from anywhere, right? So a bypass, if for the HTTPS example, it could look like, you know, just a script tag that sources stuff from attacker.com, because, you know, HTTPS kind of blesses the whole protocol, so you can load everything over HTTPS. And, you know, for the data example, you could have like a data URI with the stuff in line that would also not be blocked by CSP. So this, again, would render your policy useless. Yeah, less trivial mistakes. Quite often people forget to add object source or default source directive, right? If you just have script source self or script source none, looks pretty secure, right? It's very restrictive, but if there's no object source directive, the objects are not restricted, right? And you basically can load stuff from anywhere, right? In this example, this is maybe a little bit too complex. There's easier ones, right? But you can just load a Flash object from ajax.google APIs. You add some magic here, and you grant the Flash object script access, so the script has access to the same origin, and it's like a full XSS, basically. So we need object source as well. Then a little bit less common, less trivial. For example, if you have script source self, as we said before, this allows scripts to be sourced from the same domain. That means if you host user-provided content or stuff like that, it might be able for an attacker to upload a JavaScript file somewhere and then just source that from the same domain, right? So this really depends on your site. So the CSP might not be bypassable per se, but it is like still maybe not a great CSP. So the more interesting stuff, you can bypass CSPs quite easily if you whitelist a domain that hosts some sort of JSMP-like endpoints. I will give you an example. So in this case, whitelisted.com, which is allowed to be sourced from by CSP because it's whitelisted, has a JSMP endpoint with a callback. And the callback parameter can be used to provide arbitrary JavaScript code by the attacker, right? So if that gets, if the attacker can control this part, right, which he can because it's part of what he's injecting, this JSMP endpoint will reflect that back and say, for example, alert, blah, 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 blah. And since it's in a script tag, it will execute, right? I'll show you a demo in a second, but this is maybe a little bit, is explained in a little bit more detail here. So we have a callback with alert one semicolon u. CSP allows that, and the server kind of responds with alert semicolon u and maybe some data, right? Yes, so this is then again an XSS issue, right? Sometimes the callbacks are kind of filtered and they're more restrictive. So the amount of characters you can use is limited. But although this is not a full XSS, you can use something called sum attack, same origin method execution, to kind of simulate arbitrary user interaction, and basically it's a full XSS again. So let me show you a quick demo. So in this case now, we will use this policy. We allow unsafe inline for this example, but the important part is we allow maps.googleapis.com because we want to embed a widget, right? A map of Amsterdam, right? For example. So you can see this script is allowed to load in the browser because it is in the whitelist, right? And if we go to the right, we'll see it has a callback init map, right? So if we would, as an attacker, right, if we would inject something on the page along the line with, I don't know, alert, it will pop up, right? So the CSP is bypassed because this callback returns the alert string, right? And also, if we remove all of this, right, and the unsafe inline, the unsafe inline, it would still throw an alert because this script is allowed to load, but the callback actually returns some attacker-provided JavaScript, which gets executed in the script tag, right? So this is the problem here. What else? So this is maybe even worse, right? Any Angular library on any CDN you whitelist can be used to bypass your CSP entirely, period. It is bad, right? Because usually if you whitelist stuff on your CSP, you whitelist stuff like CDNs or things like that because they, it's a CDN, right? And they host all this kind of crazy stuff that is allowing an attacker to bypass your CSP. So why is that possible? Angular is kind of executed on top of JavaScript, right? It's some sort of symbolic execution on top of JavaScript. So basically, whitelisted.com is allowed to load. The attacker sources Angular, right? It's executed. And then he also injects some Angular tags with expression language. Since Angular is loaded, it will evaluate the expression, right? Which is already really bad because you can do everything in the scope of the application. But you can also break out of the sandbox. And that is usually very trivial because the Angular sandbox was never meant to be a security boundary. Everyone thinks so. And I think this is also the reason why they just removed it in Angular 2, right? Because to kind of bust this false sense of security. So here you have full script execution again. And as I just explained, right, CSP allows it, right, because, yeah, it's whitelisted, basically. So people could argue and say, yeah, well, maybe I just whitelist the full path of every script I have on my 1,000-page application. I will have a CSP that is like 10 pages long, but whatever, right? I'll just whitelist every full path like that, right? I just do like whitelisted.com/totally/secure.js, and I have some other stuff on my whitelist that has an open redirect, which is not so uncommon. So an attacker could not do that, right? The previous one, it could not do whitelisted.com/jsmp because that's not on the whitelist, the path. But what he could do is he could use the open redirect to point to whitelisted.com and something that is not on the path. In this case, again, JSMP callback alert. Why is that? That's probably surprising. This is kind of due to a bug that was caused by CSP. So Igor Homakov used CSP to exfiltrate sensitive data. And to mitigate that, browsers started to kind of drop the path information after redirect. So it is basically a path downgrade to just the domain. And with that, you can bypass the CSP again. But I also want to mention it is practically infeasible to come up with a path-based whitelist for your application if it has a certain size. Because sometimes the path is not even static. It changes based on JSMP parameters or versioning, whatever. So you will break your application all the time. Users will not be happy. I guess it's a TLDR. It really does not work very well, right? So this is crazy, right? Like all these bypasses and things, and I kind of got tired to explain that to developers over and over again. So I developed this tool, which basically lets you take a look at your CSP, and it will show you all the weak spots. And yeah, it is public, and the core library is open source. You can also copy that and improve it or whatever. And there's also a Chrome extension that shows you like a shield in green, red, or yellow, depending on how secure the CSP of the current site is you're surfing on. Feedback is always welcome. I hope it's somehow useful. Yeah. So when we kind of had these problems within Google, right, before that, this is probably some common pattern, right? And so we kind of did research on the state of CSP in the internet in general. And we wrote a paper about that, and it was just published 2 weeks ago at ACM CCS. And yeah, basically what we did, we took the Google search index, one of them with about 100 billion pages. We kind of spun up like, I think 20,000 machines overnight, and kind of grabbed all the content security policies from the pages, public pages we could find, right? In the end, we ended up with like 1.6 million hosts with CSP. And we also deduplicated that, so in the end we had about 26,000. So I guess a little less than 1% of the web pages in the internet have CSP, which is not a lot, right? And we also collected bypasses for the whitelists in 2 separate steps. I do want to spare you the details, but the TLDR is almost 95% of policies that try to prevent XSS can be automatically bypassed without false positives. That is a really strong statement, right? So it basically means that almost everyone who's using CSP is doing it wrong. And if you have tried to come up with a CSP for your website, you know it takes about, I don't know, half a year or a year to refactor everything and make it work with a CSP. So it is really bad, actually, right? And the remaining 5-ish%, if you look at them manually, you know, you will probably also find bypasses, so you can come really close to the 100, right? So this is terrible, right? And especially, you know, we had this very trivial example at the beginning. 86% use unsafe inline in their policy, right? So this like the policy is not even doing anything, right? So there's really a lot of false sense of security around here, right? And I really would like to bust this. People think if they have a CSP, they're kind of safe, but they really aren't in most cases, right? I will show you in a second how we think we can do that better, right? But let's assume everyone does not do the stupid mistakes, right? The common mistakes I showed at the beginning. There's still almost 80% of policies that could be bypassed because of the whitelists they have, right? Which is also bad, because this is like a systemic flaw in CSP, right? Because people have to whitelist things to make the site work. So, you know, at the median, about policies had about 12 entries in the whitelist. And in this example, if you had 2 whitelist entries in the script source, we had like a 50% probability to bypass the policy automatically. If you're closer to the median, like 12 entries, 94% were automatically bypassable. So the message is the more entries on the whitelist you have, the more likely it is that your CSP is bypassable, right? And there's like about 10 very popular whitelisted domains. They're almost on every whitelist, or at least one of them, right? And if you have if you know the JSONP or Angular libraries on these domains, you can already bypass almost 70% of the policies, right? It's super handy. The evaluator is shipped with a list of 100 domains, so it already gives you a very good approximation of the security of your CSP. So that's, if you would stop here, I would say, yeah, don't use CSP, it is useless, right? But we still think that the overall idea is still valid, right? As a mitigation, it would make sense to use CSP, right? If there would not be these bypasses, right? So a better way of doing CSP would be to use nonces. I can show you in a second, but basically you can also, instead of a whitelist, you can provide a nonce, which is basically a random value that is random on every response. And only script tags that have the same nonce value in the nonce attribute as in the header, right, will be allowed to execute. I'll show you an example in a second. And an attacker cannot inject scripts because he is not able to guess the nonce beforehand, right? This is like similar to an XSRF token, I would say. So all script tags with the correct nonce would get executed. I already said that. Tags that do not have the nonce will be blocked. And the very nice consequence of using a nonce-based CSP is you don't have to come up and maintain a whitelist, right? So that means, I don't know, reduction of a year of work, right, basically, because coming up with a whitelist and maintaining it is an insane amount of work, right? And you will have also breakages in the future with the whitelist because someone has a script, forgets it to a whitelist, and the site is breaking. So this is not the case anymore, which is a huge advantage, right? And yeah, and also the JSONP and other whitelist bypasses don't matter anymore, because with this you actually whitelist the exact path, right, and not a whitelist with a path in the CSP, but I'll show you in a second. So The nonce-based CSP is already around for, I don't know, since CSP 2, so at least, I guess, 1 or 2 years. But almost less than 1% of all CSPs uses nonces, right? And this is interesting, right? So there's probably a reason for that, and there is. You cannot get your site to work with a nonce-based CSP, right? That's the problem. So this is a very common example, a generic example. Quite often you use widgets or whatever, right? And you kind of nonce the script, and this will be allowed to execute. And then this script creates another script, you know, maybe module loading, right? With a constant, and does like document body.append child, this script. This script does not have a nonce, and therefore will be blocked by the browser. So this approach kind of breaks all the libraries out there. So you could start refactoring the libraries to manually pass on the nonce, but to be honest, that would never happen, right? Because you don't control the libraries. Even at Google, if you own some of the libraries, right, it's just not scalable, this approach. And this is, as I said, a very common pattern, so you cannot really use it. So this is an example. How does nonces work? You have a script, nonce random, and the policy also has the random string, right? And only if these two match, the browser compares the header with all the script tags in the body, then it is allowed to execute. And this works for inline scripts and sourced scripts. So an attacker that just injects an inline script or a sourced script does not know the nonce that is in the header, right, in the response, so he cannot guess it. So this is also why it should be random and different on every response. So both will be blocked. Let's do a super quick example. So this is a nonce policy, and this is the policy from before. It has random here, right? And it also has random here, so both scripts are allowed to execute because they match this random value here. But if you take a look here, right, it already says, refuse to load the script maps API / API.js 2614 stats.js, right? So it does some, the maps widget does some module loading, right? And if you see, it did fall back to an image. It is not interactive anymore. So it actually broke the widget, right? And this is exactly what I was talking about. You cannot use that in a normal web application usually. So what is the solution? We came up with an extension to CSP 3, and it's basically a new keyword called strict dynamic. And what it does, it kind of transitively propagates trust to child scripts if they created in a certain way. So if a script source has a nonce or a hash directive and script dynamic is present, the whole whitelist on the CSP in script source is discarded, deleted, right? This is for backward compatibility reason and also to prevent developers from shooting themselves in the foot. And it will allow JavaScript execution that is triggered by non-parser inserted active content. So I will show in a second what that means. And with this extension, in practice, a nonce-only policy is feasible. So what does strict dynamic do? We saw the previous case, right? This is allowed now. If you use like the JavaScript API, like the DOM API, body, append, child, it will automatically transitively propagate the trust from this allowed script to the child script. What will not be allowed is parser inserted scripts. So every time the parser is involved in the browser, like document.write s and then some string, this will not be allowed and not be blessed by strict dynamic. Same with inner HTML. So this is a very defined API, and the nice thing is suddenly you can have one policy for every application. It is the CSP basically became a constant apart from the random part in the nonce, right? You don't have to come up with these crazy policies anymore, right? You basically can use this one fit policy for everything. And I will explain in a second why we have these unsafe things here, right? So let me show you a demo first. you saw there were some issues here, right? If I now use the strict dynamic with fallbacks, suddenly it renders, right? And I can even remove the fallbacks because this, we don't need the fallbacks here in this example because we have a decent browser. And you see there's no violations because the child scripts created by this one now are also allowed to execute. So why do we have these weird strings here? You basically can do with just that, as you saw, in a modern browser that supports CSP3. But if you just have the first part, it will break in all the browsers that only support CSP2 or CSP1, right? So there's like some crazy fallback mechanisms in CSP that make everything really confusing, but it kind of works, and this is how it is. So a CSP3 compatible browser would just see that because a nonce or a hash drops unsafe inline, right? And strict dynamic, as I said before, drops every whitelist entry. So in this case, HTTPS or foobar.com. So this is the effective CSP. A CSP2 compatible browser will not know about strict dynamic, but it will know about the nonce. So it will drop unsafe inline, but it will still have the HTTPS. So in this case, the CSP is a total no-op, but it will also not break your site, right? And in a CSP compatible browser, like, so this would be, I think, Edge. You know, it is a fallback to just unsafe inline and HTTPS. So everything is allowed to execute, but it will not break your site. So you can either do user agent sniffing and have the CSP just until here, right? Or if you don't want to do user agent sniffing, you can serve the CSP with the fallbacks, and all browsers that start supporting CSP3 will be protected, and all the others just won't. But it is still better than the whitelist-based approach because in this case, you don't have any protection at all, right, in no browser. Also very important, the limitations. So a strict CSP with strict dynamic kind of reduces the attack surface in the sense that it kind of removes reflected and stored XSS and a lot of DOM XSS. But if you do stuff like that, script source, some user input, something, that will not be blocked by the CSP in this case, right? But so compared to the whitelist approach, this is still magnitudes better, right? Because the whitelist approach did not do anything at all. And this is maybe, I don't know, a very small fraction of the attack surface, right? So you basically exchange a CSP policy that is useless for almost every website to something that is secure by default, easy to adopt, and only bypassable if you have a certain XSS vector in DOM XSS. But you can also you can kind of audit for that in a more targeted fashion than just general XSS, right? So what about the browser support? It is the case that Chrome supports it already now in stable, also Opera, and I learned yesterday that Firefox has it in nightly since yesterday, which is pretty cool. And Firefox will support it in stable starting from version 52, I think. So this is pretty cool because all the major browsers support it. And yeah, I think Edge is working on it, so they still need to implement nonces first. So they're a bit behind schedule here. And I think, IE is lost ground, right? So if you use IE, then you probably deserve to. I mean, I don't know. So that's still very good, right? It's a new feature, but it's already kind of widely supported. Thank you. So this all sounds very theoretical, right? But we actually implemented strict CSP already in a couple of Google products. So at the moment, I think a strict CSP is served to already over 300 million users. And the interesting thing is, a team of 2 people basically were able to change products from a kind of useless CSP or no CSP to an actually effective CSP within days or sometimes weeks, right? So we kind of refactored like 15 big products to use a strict CSP, which is really amazing if you compare it how hard it was previously to come up with a whitelist and not break the product, right? So some examples that have a strict CSP right now is Google Photos, Google Jobs, then the bug tracker for Chrome, which is also used by Project Zero, then I think Maps activities, and a couple of the Cloud Console, I think, and a couple of other products, and there will be more soon. So yeah, and we also did some case studies with a lot of common widgets to try out if they work with strict CSP. So as I said before, if you use create element for creating a subscript, it works. If you use document write, it does not, right? So at the beginning, we were kind of afraid, maybe we're breaking a lot of widgets because we're kind of not allowing document write. But it turns out that most widgets are actually sane and not use the crazy document write that often. So a lot of the very popular widgets, they just work out of the box. I'm pretty sure there's some widgets that are maybe breaking, but if you use document write, it's actually a really big anti-pattern in the first place and very risky anyway. So it makes sense to refactor these, but we have like a small test bed for this experiment. It's called csp-experiments.appspot.com, just a site that loads a lot of widgets and has a strict CSP, and you can see that they are still loading, right? So yes, I would say it's your move now. For all the security pen testers among you, if you're in the next audit and someone has a CSP, right, they're probably very likely to have a whitelist-based CSP, and I guess with the stuff on the slides, you can easily show them that the CSP is actually not providing any value, and you should let them know and help them to pass this false sense of security. And you can also suggest them to instead use a nonce-based CSP with strict dynamic. It still requires the same refactoring as with the CSP before, so you have to refactor out the inline event handlers and ideally also inline scripts, but you don't have to with nonces. But there's also frameworks that do auto-noncing for you everywhere, right? So for example, closure templates, I don't know if you know that, but you kind of provide the nonce, the script, the CSP nonce to the template system, and it automatically nonces all the scripts in your markup. But these templates have to be context sensitive, right, to not nonce shady stuff. So that works really pretty well, and we're kind of trying to push more frameworks to support this auto-noncing in a context sensitive way. But yeah, I think that will also help to increase adoption. Yes, and yeah, please tell everyone that whitelists are really not safe to use. So, do you guys have any questions around this topic? And slides are online here if you want to download them.
Hello, thanks for the talk. Until now, I was only aware of like the old CSP, or what you say, whitelist-based CSP. Yeah. It seems to me, despite everything what you said, that there are still situations where you can reasonably do that. Like if you have a web page where you're not using third-party scripts and not that much JavaScript at all. And so my question would be, if you can feasibly create a secure whitelist, would you still create a whitelist, or would you still like use the strict dynamic version of CSP?
So that's a very good question. Thank you for that. So
because they're incompatible, yes, as far as
yes. So probably 99% of all the people will not be able to use a whitelist-based CSP, a secure one. The requirements to use a whitelist-based CSP that actually protect against XSS is that you, for example, do what GitHub does, right? You have one whitelisted domain that is, for example, stuff.github.com, and they have like, I don't know, 3 JavaScript files there. So they actually are in full control of the domain they're whitelisting, right? And they know exactly which scripts they're sourcing from there, right? They can do that because their application is very isolated, right? They don't use any third-party stuff. So it works for them, but if you look at most of the other policies you see, right, you see that a lot of stuff gets sourced from CDNs and widgets, right? So if you can do that, yes, it is a feasible way, but you should really make sure that you have in full control of this one domain and that none of these scripts have a JSONP-like bypass or an Angular library. So if you have a security team that is capable of doing that, yes. If you don't have a full security team to monitor that, maybe you should default to something that is easier to implement and easier to not get wrong, right? And maybe in this case, you can even just use nonces, right? If you don't have dynamically created scripts, maybe you can just use nonces as well. Then you don't have this small increase of the attack surface through strict dynamic. But all in all, I think it's still a good trade-off.
Thanks for the talk. Just one question. What's the risk of the nonce being compromised?
So what is the
risk of the nonce being compromised?
So it is very similar to an XSRF token, right? If you set a static nonce, it is useless, right? If you set a really short run nonce that can be brute forced easily, it is also useless. If you, I don't know, reuse nonces over user sessions, it's also useless, right? But it is not hard to get right because you just have to create a long random token on error response, right? So we're already doing that in a kind of working way with XSRF tokens. So we basically can use the same random number generation logic for that, right? But I'm sure there will be people who generate like, who will just copy the slides and will have nonce random in their application, right? So you will see that in the wild, right? So of course.
Hi, I'm just wondering how does it behave when you load content to the page dynamically? For example, you have a search and you want to load more content and you have a second random number. How does it behave?
So you can load stuff dynamically, right? Because the scripts can always create new scripts if they are blessed initially, right? The assumption is that once you're in a blessed execution context, you can still generate dynamic scripts.
I thought of if I load from my server more content, which may have some kind of JavaScript maybe inside, and the random number changes because I have a new request.
So if you navigate to different site, also the header will change, right? And then, but I mean, if you do like I don't know, a request. I don't know, XHR, did you mean an XHR? Yeah, so an XHR is independent from that, right? Because it is kind of, you just take the data out, right? It's not rendered in this sense, right? So yeah, you're already in a JavaScript execution context when you do the XHR, right? So you can, of course, do that.
Any more questions?
Very interesting talk, thanks. I was wondering, since you said that you would generate a new nonce at every basically request,
response,
right?
Yeah.
Response, yeah. Wouldn't it be possible then to have a session exhaustion attack there, or are you keeping any session information there?
You don't. So
or
that's
state,
a very nice
right
thing
word,
because
yeah.
you don't have to keep the state on the server, right?
Okay.
You just generate the nonce. Where is the slide? You just generate the nonce once for the response, and then the server forgets it.
Okay.
Because actually who's enforcing the CSP is the browser, right? The browser just looks at the header and the scripts, and if the values don't match, it does not execute the script, right?
Okay.
So you don't have to keep a state. This is very nice.
Okay.
And maybe something I should mention, you can also use CSP hashes with strict dynamic. So you can hash an inline script that you trust and kind of use that for dynamic trust propagation as well. So if you, for example, the CSP, one second. If you look at the page source here, it has no nonces because it's a static page, right? But what it does, it creates a bootstrap script that loads all the child scripts, and this hash is in the policy, right? So only this script is allowed to execute in the first place, and its dependence, right? So you don't ever have to generate a nonce for this example, but it's a bit advanced.
You showed us the example of strict dynamic disabling other
Yes.
statements. So this is like it creates invisible dependencies because you have to know that this tag will disable these other tags on newer browsers, but not on old browsers and stuff. Wouldn't it be better to have something like explicit versioning for, okay, this is my policy for
Yes.
browsers with version 3, and this is my
I
policy
think the
for...
CSP spec is not optimal because it's very old and is growing, right? And the versioning in the CSP would be great, right? Because then we would not have to do that. But the problem is, if you don't drop the whitelist, there will be developers that have whitelist entries right next to the strict dynamic and other things, and they will again make the CSP break. And we wanted to make it kind of foolproof, right? If you get the whole whitelist dropped, then you cannot kind of make it.
Yeah, I
again,
understand
right?
why you drop
but
it.
I really agree that that would be very nice if CSP would have versioning.
Yeah.
Yeah, and yes.
About the nonces, have you considered if you're not using a secure random number generator? Because, like, I'm aware in PHP, for example, it's not trivial to get a secure random number. The secure functions are only available in PHP 7, and in PHP 5 you have to use an OpenSSL function that's not always available.
So the thing is, it is not so easy to brute force the random number, because as an attacker, you would need to kind of inject millions of scripts on the same page with different nonces, right? So it's not as easy as brute forcing something remote, right? It is, I would say, it should be very random, right? But if it's just long and somehow random, I don't know, it's just harder, right? But I agree, it is, I mean, it's really important that you just reuse a library for that. That has been proven to be effective. But in this case, you know, XSRF tokens are already around for a long time. So I would hope that you can reuse that in most frameworks, right? And just not reinvent your own tool there. But yeah, it is still very hard to exploit, I think, if you can guess the seed, of course, you probably can get it easy, right? But it's not so easy to brute force it from the rate perspective.